To wrap up our unit, we're going to look at section 11.3, which deals with polar coordinates. And if you've taken a trigonometry class before, you've most likely dealt with polar coordinates in the past. But if you have not, or if you need a refresher, I'm going to just briefly go over how these points work. Polar coordinates are going to start out with a fixed point, which is called the pole. And in the Cartesian system, that pole is typically the origin, the point 0, 0. And then there's going to be an initial ray, which again, in the Cartesian system is typically the positive x-axis. That's our initial ray. Then to define a point, and in this case, I've got the point labeled as P, instead of it being given an x and a y coordinate, so just a distance horizontally and vertically from the origin, it's given a point in terms of r and theta. Theta is going to be the angle between the initial ray and the line segment that connects the origin or the pole to your point. And then r is the distance of that line segment. So when you're given a polar coordinate, it's going to be, again, r theta, where r is the distance of that line segment, theta is the angle. Now, couple things to keep in mind. The way we measure angles is that we start at angle 0. So that x-axis, let me come to this picture here. The x-axis here would be theta equals 0. And as we go counterclockwise, the values of theta are going to get larger. Okay, so in this picture, it's labeled the y-axis, or at least the positive y-axis, would be pi over 2. The negative x-axis would be theta equals pi. Then continuing, we'd have 3 pi over 2 down here. And then we hit the x-axis again, and that's 2 pi. And you could continue spinning around here if you wanted to. If theta is given as a negative, that means that we're starting at the positive x-axis, but we're going clockwise. So you could have a negative theta. Just remember that that angle is going clockwise rather than counterclockwise. Additionally, you could have a negative value of r. The negative value of r would indicate that you're on that theta angle, but you're flipped in the opposite direction. And I'm actually going to do my examples slightly out of order here because I want to really show what that negative value of r would look like. So I'm going to jump over here, or rather scroll down to the second page here, where it gives us two sets of equations and inequalities. The first one, we're given that theta is pi over 3, and that r is going to be between -1 and 3 inclusive. So I have a polar graph, and in this polar graph you can see the common angles are labeled. So we'd have here 2 pi, which is also our starting point 0, then pi over 6, pi over 3, pi over 2, and it continues around. And then these little dashed circles represent our r values. So this is r equals 1, this first innermost circle, then r equals 2, then r equals 3 is the outer one. So to graph this first equation and inequality, it says that theta is pi over 3. So we're going to be along this angle here, and that r goes from -1 up to +3. So along this angle here, -1 would be taking this angle, but going on the other side of the origin. So we would move 1 unit to the other side of the origin. So that would be the -1 point. Would be down, there we go, would be down here. And then it's going to continue all the way up, staying on that same angle until we get to r equals 3, which is out here. Well, that was not a very pretty. Well, I'm not doing a very good job of drawing a straight line, am I? Let me try that one more time. But what you would have would be a line segment between these 2 points. I'm just doing a really horrible job of trying to draw it today. That's a little bit better. You get the idea. For the second example here, R is fixed this time. R is 1. So we're dealing with this circle here, this innermost circle. And the theta values are going to change from 0 all the way to pi. So remember I said where it's marked 2 pi, that's also 0. So that's where we're going to start, and it's going to go all the way around to the angle pi, following, and I'll do my best, following that curve. So you'd have a half circle there.